All right, welcome to Chapter 11, Section 6, called Perpendiculars and Distance. This is for Integrated Math 1, or IM 1. All right, so just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a Submit Assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the Submit Assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click Submit Assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the gradebook when you click that button so that your teacher can see what you've been working on and, hopefully it will improve your grade there. All right, on the side, we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt, because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you, because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. Of what are we doing for the distance? All right, so when we want to find the distance between 2 points, and one thing that we should notice is if I kind of stack these guys, do we notice how these are the same? Well, the x's are the same. What that means is that if I had a coordinate grid here and I went over to -6, we're going to pretend like this is -6, I'd go down to -5 and put a point, and then I'm still at -6 and I go up to 3. So they're directly above and below each other. So if we have a matching coordinate, it means they're either right above each other, like this one, if it's the x's. If the y's were the same, then they would be left and right of each other, because I would stay on the same y coordinate for both, if both y's were the same, if we had an example like that one. So when we have it like this, really I just want to know what's the distance between -5 and 3. So make sure you're paying attention. There's 5 here and then there's 3 here. So even though it's a -5, it's still a distance of 5 from kind of the 0 line here, this axis. So it's a total of 8. So don't do -5 or 5 minus 3 and go, oh well, it's 2. No, it's 5 negative, so 5 below and 3 above. So it's a total of 8 for the distance. And sometimes just drawing a little graph like that can definitely help us visualize, okay, well, what's the actual distance? We have find the distance between points A and B given below. That is, find the length of the segment connecting A and B. Round your answer to the nearest hundredth. So with this one, and I'm going to draw A, B like this. So I don't have the grid, but we'll use the grid on the other screen here. What we're going to do is we're going to kind of connect this into a triangle. So I'm going to draw a line straight down and then a line straight over like this. Straight down and a line straight over like that. And that should create a 90-degree angle because it's on this nice grid where they intersect. So what I want to do is count and go 1, 2, 3. So this is 3, and then this one is 1, 2, 3 also. So they both have a length of 3. If we go back to Pythagorean Theorem, we have a right triangle, A, B, C. Remember, A and B are the legs that make up the 90-degree angle. C is the angle across from the 90 degree, which we call the hypotenuse. That's the longest side. So if this doesn't sound familiar to you, if you're a little confused with this, go back and watch the videos for section 5.5 and 5.6, because I do go over the Pythagorean theorem, especially in 5.5, that's where it's introduced. So I would go back and rewatch those videos if this sounds confusing, if it doesn't sound familiar yet. All right, so we're going to go ahead and use this, and we have a squared plus b squared equals c squared. So this is the Pythagorean theorem, this piece here. This is the diagram, the triangle. This is the actual theorem. So if this is a and this is b, these are the legs that make up the 90, so that's a and b, then this part is my c, the length that I'm looking for. So we'll have 3 squared plus 3 squared, a squared plus b squared equals c squared, which I'm just going to be lazy and call ab, just so that I don't have to rename it. So I have 9 plus 9, because 3 squared is 9, and 3 squared is 9, ab squared. So 9 plus 9 is 18, not 81. I'm not multiplying, I'm just adding. So then I have ab squared, and I'm going to take the square root, because I want to know what number multiplies by itself to get 18, or what number multiplies by itself to get ab. Well, ab times ab would get me ab squared, so I know the square root is ab, just one of them. 18 does not have a nice square root on it, so we're going to click on the square root button here, and we're going to click 18 and see what's our decimal. And it says it round to the nearest hundredth, so 24, that 2 is a tenth, 4 is a hundredth, so I'm going to go one past that, because that 2 helps me decide, am I rounding the 4 up to 5 or am I leaving it 4? Since this next number is 4 or smaller, it's just going to stay. Everything else just rounds off. So it's 4.24. All right. Continue. And I think, let's see. So we're going to do the exact same idea here. I was trying to see, does this actually connect directly to the distance formula? It does. Okay, on number 3, we relate it. So with this next one, all right, I'm going to erase that guy. So now the blue line's just going in a different direction here. So now we have like this, A, B. We still want to know what AB is, but I'm going to draw that same thing. I'm going to draw a line straight down and straight across so that I create that 90 right at that grid line there. So this one I just want to count 1, 2, 3, and then 1, 2, 3, 4, 5. And when we did this in class, I know you guys had these grids to actually draw on. That might make it a little bit easier if you actually have a grid to draw on. I know we have grid paper at our center that if you need extra grid paper, you can ask for it, or we could even print some up from the internet. Pretty easy to find. So if you need some, definitely ask for it. It can make it a little easier to have it sometimes, I think. All right. So now we have A, B, and then C. So it's going to be 5 squared plus 3 squared, A squared plus B squared equals C squared, which is AB squared again. So we have 25 plus 9. 5 squared is 25. 3 squared is 9. And so 25 plus 9 is 34. 34 does not have a nice square root on it, so when I take the square root here, I'm going to get another decimal. I'm still going to get AB on this side, but I know I'm not going to get a nice number on the other side here because it's not a perfect square. So it says round to the hundredth again, so I'm going to go, here's tenth, here's hundredth, so I'm going to go one number past it, which is a 0. That's definitely 4 smaller, so it's just going to drop off. The 3 stays a 3. All right. From there. There we go. All right, consider the line y equals negative 8x plus 8. So we have our slope and we have our y-intercept. Find an equation of a line that is parallel to this line and passes through the point 6, 2. Okay, so now they're asking us to do something a little different. We just learned point slope in the last section. So what they want us to do is go back to point slope form, which I'll try to do the color coding that I was doing here. We have y minus equals x minus. All right, so with this one, we're going to have a point and we're going to have a slope. So either way, we have to deal with slope here. Slope gets multiplied by x. Y is being subtracted from the y coordinate. X is being subtracted from the x coordinate. So we have now a point and a slope. Well, the reason they gave us this equation was just to grab the slope from it. So this is slope-intercept form, so I know my slope is -8. If I have a parallel line, so parallel, that's going to be slope of -8. If I have a perpendicular line, perpendicular, I spelled that really, really funny, perpendicular, then I'm going to have the slope of the negative reciprocal. Remember, there's a 1 under here, so I know we don't always put it there, but we're going to flip it over, and then it was negative, now it's positive. So there are my two slopes that I need to write these equations. And I'm going to use this point slope form. I'm given a point here, so I already know what my y and my x are going to be. So and I'll start with parallel, since that's the first equation they're asking us to do here. So y minus equals x minus, and I'm just filling this part out. Then we're going to do the same thing for the perpendicular one, actually, so just so I don't have to keep flipping my colors here. So the point they're giving us is 6, 2 for both of them. So remember, it goes x then y. I have my y minus my y coordinate and my x minus my x coordinate. And I can fill those in for both of them. It's the same point for both. Now what I'm going to fill in is my slope here in front of the x. So for parallel, it's going to be the same slope. For perpendicular, it's going to be the negative reciprocal. And be careful when I say negative reciprocal, I'm just saying flip it over and flip the sign. Doesn't mean that it's going to end up being negative. If we started with a negative, it's going to be a positive. I'm applying a negative to it. I'm flipping the sign is what negative reciprocal means. All right, we can type these guys in just like this. It didn't say what kind of equation we had to write. It wasn't being specific on, point slope or slope intercept. So these are legitimate equations in point slope. We are good to go. X minus 6. And then I'm going to be a little lazy here, and I'm going to copy this. So I'm going to Control C, and I'm going to Control V, that paste it. And now all I have to do is go like this and go 1/8, and I can fix it really easy instead of having to retype the entire thing in there. Uh-oh, which part did I type incorrectly here? Oh, I put a negative on there. I forgot to take my negative off when I copied that. There we go. Recheck. All right, there we go. So, and you can use the graphing calculator in here. It opens up. You can type in some lines. You can actually get to see how they react to each other on here. You can change the colors if you want to, things like that. So the graphic calculator can definitely be a good visual tool. All right. So let's go ahead and keep moving here.